Scale Up Nation, I get people asking me all the time, how do I read so much as busy as I am? And the secret is, a lot of my reading people do for me. That's right, I use Audible. Audible is a service that will read books to you and allow you to get the content while you're driving from account to account. I've been using Audible for years, and you can try it for free, one book in 1 month for free on me through our affiliate link, scalinguph2o.com/audible. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. I'm Trace Blackmore, the host of the Scaling Up H2O podcast. And Nation, last week you heard one of my friends, one of my mentors, Scott Slade, if you listen to episode 371. And Scott Slade has the most amazing voice. And if you heard last week's episode, I don't know how you're listening to my voice. I listened to Scott's voice. But my other favorite voice in podcasting is Mike Rowe. He's got a podcast called The Way I Heard It. And those two, Scott Slade and Mike Rowe, are my two favorite podcast voices. And I try to enunciate like those two gentlemen. I try to see, how their cadence is, how they flow. So I find somebody that I really admire, that they are knocking it out of the park of whatever they do. And then I try to see how they do that. And I will break that down and see, is there a pattern that they use? So just a little insight in the mind of Trace Blackmore, but a little more about Scott Slade. As you heard last week, he was a student of mine for scuba diving. I'm a scuba dive instructor. And then afterwards, he was so gracious. He said, Trace, you did such a good job preparing me, making sure that I'm safe underwater and know what to anticipate. What can I do for you? And at that moment, I said, Scott, I've been listening to you for years, and I just started this podcast. I would love it if you could give me some pointers. And he graciously said, absolutely. He helped us out with the equipment that I currently have and invited me to his studio so I could see how he did what it was that he did. And he truly is a conductor, just orchestrating all the things that had to go on during that morning show. I mean, I just get to talk, and I've got an editor that puts all of our guests together in one file so you can listen to it. Scott had to conduct that all himself. He had the weather guy, the traffic guy, the financial guy, all of those people. He had to make sure that he was reading in properly and bringing it in live. It was just amazing watching him do all of that. Well, in addition to that, Scott is also a pilot, and Scott is encouraging me to do ground school so he can teach me how to be a pilot. And that's been on my bucket list for years. I actually see a very plausible way that I can check that off my bucket list now. So that is something that I plan on working on. I'm not actively working on it, but it is in my future plan. So a couple of things from this intro. One, if there is somebody that you admire because of how they do what they do, ask them to help you with that. I am such a big fan of asking people to mentor me, and I can't tell you how better of a person in you name the area that I am because I found somebody to help guide me to be that better person. And there are just so many people on that list that have helped me throughout my life become better at whatever I was endeavoring to be better at. And the other thing is, I hope you get, do you have a bucket list? The brutal fact is life is very short. And how are we making the most out of our lives? And a lot of things that we want to do within that lifetime, are we actually making sure that we are doing that? Now, Tim Fulton, one of my business heroes, you heard him on episode 368, and you, of course, have heard him on several other episodes. He was the one that started me doing a bucket list. And when people start to work for our company, I ask them, what is on your bucket list? And I will say most of them say, I don't have one. And during the orientation of our company, I said, you need to create a bucket list. And you and I are going to try to figure out how we check one item off this year. Now, I love it when people say, I've always wanted to become a scuba diver. That's one of the easiest things for me to do because I'm a scuba dive instructor. And I've had a few people say that that's what they want to do. And they are now scuba certified. And I got to be part of that process. There was one person that said they always wanted to go to an Atlanta Braves game. Well, folks, the Atlanta Braves are right here. And I know several people that can help me get tickets, even to difficult games. So that was a fairly easy one. And he had the time of his life. And we were actually able to get into a special section where they actually serve food and you got to go down to a special lounge area. So he just thought that was great. And that was because, one, I encouraged him to do the bucket list. He shared that bucket list with somebody, i.e., me. And because I did the same thing, I'm always looking for people that can help me grow and I can help other people grow. I knew somebody that was able to get me not just tickets, but really special tickets. We were pretty close to home plate. And we had that special lounge. So I hope this inspires you to not just listen to people or not just be aware of people that you admire, but ask them, how do you do what you do? And can you help me do what I'm trying to do better? You know, something that a lot of people are doing to try to improve their skills is going to conferences. And thank goodness we are post-COVID and we can go to in-person conferences again. And I want to tell you about a few. So the International Water Association is having their World Water Congress and exhibit August 11th through 15th in Toronto, Canada. So we're going to have information about that conference on our events page. And while you're there, check out the conference hosted by the National Rural Water Association. And the conference is Water Pro. That's taking place September 9th through 11th here in my home state of Georgia in Savannah. Folks, if you've never been to Savannah, Georgia, that is an amazing city. Great restaurants, too. So go for the restaurants, go for the conference, and we're going to have information on that conference on our events page. And then finally, the 97th annual WEFTech 2024 Technical Exhibition and Conference is taking place in New Orleans, Louisiana, October 5th through 9th. So all of those shows are going to be featured on our events page. And while you're there, you can check out every single event that we know about because we know how hard it is driving from account to account. You are making sure that your customers get the best service possible. So we want you to get the best service possible when you go to the scalinguph2o.com website. Nation, I love meeting new people. I love you meeting our new people, our new guests. So here is our next interview. My lab partner today is Jed Harris, owner of Puretec. Jed, welcome to the Scaling Up H2O podcast.
Hi, Trace. Happy to be here.
Well, we're going to talk all about RO systems today, and I'm super excited to do that. More and more people are having to do more with the water that they have on site. And of course, ROs are part of that. So if our listeners haven't seen RO systems in their portfolio, they're probably coming. So I know people are going to get a lot out of that episode. But before we go to that, do you mind telling the Scaling Up Nation a bit about yourself?
Sure, yeah. So my name's Jed Harris. I'm one of the owners at Puretec. We're located here in Southern California, and we service the southwestern United States. We provide high purity water solutions for dozens of industries that require high purity water as either a rinse or an ingredient or thermal transfer in their operation. I've been in this business now for a little over 25 years, believe it or not, and I'm still learning. That's why I'm really grateful for people like you that are really creating some excitement in the industry and encouraging people to really learn and grow within the water treatment industry. So thank you.
My pleasure. Thank you for saying that. My dad taught me the day I didn't learn something new in water treatment was the day I needed to find a new career. And water treatment has just been the industry that keeps on giving with being able to teach you new things each and every day. If you listen to the podcast, you probably heard me say, if you're not learning something new every day, probably take my father's advice. I'm kind of curious though, how did you get involved in this industry?
That's a good question. So my father had a Culligan dealership in Southern California. So I was really involved with the business ever since I could push a broom. And he never really fit under the Culligan umbrella, though. He was always involved with the industrial, the high purity side. And I really was fortunate to learn and have such a great mentor. He was doing a lot of neat things. So, kind of fast forward, I graduated high school, I went off to college. And then after college, I worked in Silicon Valley in the tech industry. And this is like 1999, 2000. So that was a very interesting time to be up there. But my father called me one day and said, "Hey, I really need help. Here at back then it was Culligan, and in the regeneration plan and the operations." And so, you know, Monday morning there I was, and I was back in the business, and it was such an amazing time to be back in the business because this was the time when U.S. Filter, Dick Heckman was basically acquiring everything in sight. So I'll never forget. He came to visit us, and he said basically, you can cooperate with us, you can accept our offer to buy you, or we're going to compete. And if you do the latter, you're not going to survive. We're gonna price you out and cut off the supply lines. And I'll never forget that. So he left, and my father and I kind of looked at each other and said, "Screw this guy. We're just going to change our name." So one of our salespeople came up with this name, Puretec Industrial Water. So we went outside and painted our trucks and just got back to work. And that was about 24, 25 years ago. And so here we are. We're doing great, and look forward to the next 25 years.
I love stories like that. The entrepreneurial spirit is so alive in our industry.
Yeah, you bet. You bet. There's a lot of great people in this industry, and a lot of opportunity.
Well, let's go ahead and talk about reverse osmosis. And like I said, Scaling Up Nation, if you do not have an RO in your portfolio, most likely it is coming. And let's just start there. How would you define reverse osmosis?
To define reverse osmosis, so like you said, reverse osmosis is the workhorse, really, of the water treatment industry. So reverse osmosis is basically taking water using a high pressure pump to force it through a semi-permeable membrane, this RO membrane. And doing so, you're reversing this natural osmotic pressure in the water that's based on the feed water composition and so forth. So, I mean, in really simple terms, it's a filter, and it's going to remove the bulk, let's say up to 99% of dissolved solids, organics, bacteria, viruses in the water. And again, it's this workhorse. It does the bulk of this contaminant removal. And a lot of applications are perfectly okay just using RO permeate water, RO permeate the product, the water that the RO produces. A lot of applications are fine just using RO permeate water, but many times it requires further treatment, like with ion exchange, UV, and there's considerations with how the water is stored and distributed and so forth. But I hope that gave an answer. I was trying to explain it to my 10-year-old, and I don't know if this is right or wrong, but I used a cheese grater as an analogy. Like you're pushing the cheese along the grater and the cheese falls out the bottom. I don't know if that's an analogy that'll get your mind going on this, but essentially you're reversing this osmotic pressure, forcing the water through a semi-permeable membrane. And as long as you have adequate feed pressure, you are able to push the water through the membrane and get the RO permeate, which is much higher level of purity.
I think the best definitions are the ones that the 10-year-olds understand. So I like that analogy. I think that's an Albert Einstein quote. You don't really know something unless you can explain it to a fifth grader or something like that, I think he says.
Yeah, that's a great quote. Well, I don't think my 10-year-old still understood it, but you're right. Another quote I heard is sorry for the long letter. I didn't have time to write a short one.
I think that was Mark Twain, wasn't it?
Yeah, that's right. You're right.
Yeah.
That was. Yeah.
Where are some of the most common places you're seeing RO being used?
So I would say certainly in the industries with major water use, like power generation, food and beverage, you have pharmaceutical, and then there are hundreds of uses across dozens of industries for reverse osmosis. And again, we're really on the high purity water makeup side. Sometimes people use reverse osmosis to take the concentrate. They're trying to purify whatever product. Personally, I don't have experience with that. It's mainly on the water makeup side. So again, very versatile tool used all over. Don't forget the municipalities, desalination, which of course happens more overseas. It's a tool that is used very far and wide.
What are some of the biggest issues that our audience should be aware of when it comes to RO?
So an RO system is it's a rather simple machine. However, the feed water chemistry of the water and various changing dynamics make a very complicated overall system to manage. So it's critical if you are responsible for maintaining an RO system to really understand how to maintain it, to analyze the data, to understand what this RO system is telling you. And then finally, I think there's a huge push towards operating at a very high recovery rate with RO systems these days. And that's presented a lot of challenges. We're really pushing the RO system beyond what is really perhaps intended or understood what it should do. And I think we're all going to see more and more of this. And when you start having this conversation about how to effectively maintain these systems that are really being pushed right to the edge, and the scale inhibition time is down to minutes now. It's really a different world we're entering with that, and it poses a lot of challenges.
We've been throwing out a lot of quotes on this episode. So another one, Peter Drucker, what gets measured gets better. So obviously we need to measure what's going on with the RO. What are some of the key things that we should be looking at to be able to tell what's going on within the RO?
Yeah, that's a fantastic question. So you want to look at your flows, your qualities, your pressures, and last but not least, the feed water temperature, which has a huge effect on all this stuff. So you want to look at your permeate flow, your concentrate flow, your feed pressure, your concentrate pressure, and your permeate pressure if available. And then the qualities would be your feed conductivity and your permeate conductivity.
Now, you have a great paper on your website that I'd love to share on our show notes page, if that's all right.
Absolutely, yeah.
You say it's not just about collecting the data, but you've got to normalize that data. Talk a little bit about that, if you don't mind.
Absolutely. So that's the tricky part. Number one, if you're collecting data, you're off to a great start because a lot of people, they don't even collect the data. Ideally, if you can, you want to collect data at least once a day. The example I just gave you, that was 8 data points. And you can look at all these individually and start to make assumptions, but you have to normalize this data in order to make sure you're really comparing apples to apples. So by normalizing the data, what you're doing is essentially you're taking data when you start up the RO system. So you have new membranes in the system, or you just clean membranes. So they're relatively new. And something to note here that's really important is before you take that baseline data, it's a good idea to let those new membranes stabilize for perhaps like 48 hours. The permeability of the membrane really settle down and become stable. That's a mistake that we see sometimes when you take data right away after replacing the membranes. But getting back to your question, the normalization, so you take this baseline data, and then as you go into the future and you're collecting data, you're able to normalize that data to the baseline data. So you're comparing the current performance to how it should be at the baseline. And that way you really understand, is this thing tanking or is it okay? Or, do we have a big problem? And as you know, and maybe some of our listeners aren't aware, temperature has such a huge effect on the amount of water that will go through a membrane. RO membranes are just like the Miami Dolphins. They really don't do well in cold weather. So
you're pretty good with analogies.
Yeah. So I think the rule of thumb is for every 1 degree Fahrenheit drop in water temperature, you're going to lose about 1.5% in permeate flow. So you might notice a decrease in permeate flow and you're thinking, hey, these membranes are dirty, they're plugged, we need to clean, something's wrong. But in reality, nothing's wrong. It's just that the feed water temperatures drop.
Can you give us an example where if we're just taking data points and we're not normalizing, what's the false sense of security we may have, or what possible issue might we think we have that we don't? How does normalization help with that?
Yeah, that's a great question. And we've been guilty of that many, many years ago. Again, I would say number one is the feed water temperature. So let's say it's summertime and your RO system is producing 100 gallons per minute of permeate. And then wintertime comes around, and let's say you drop 10 degrees. So you would have a very, very significant drop in your permeate flow. And you might assume that, your RO system's plugged, something's wrong with the membranes. But again, nothing's wrong with them. They're performing just as they should. It's just the fact that the feed water has become colder and it's more viscous and it's thicker and it has to work harder to get through that membrane. So that's an example where if you normalize the data, then you would notice that your normalized permeate flow is actually flat. It hasn't changed. And that way you know, hey, you're okay. Now, something with the normalized permeate flow that's important too is that a lot of our customers have asked us, they said, hey, you're telling us that our normalized permeate flow is let's say 100 gallons per minute. But we're going out to our water pad and we can actually read on the flow meter, it says it's 120 gallons per minute. So it's important to understand that when you say normalized permeate flow in gallons per minute, that is a calculated value. It's not the actual value coming out of the RO. We get that question a lot. But that's just one example how temperature and pressure and the feed water quality, these all interplay with each other. And you really have to normalize that to your baseline values so you know things are okay or not, or we have a big problem we need to get ahead of.
In the beginning of the interview, you mentioned 8 different data sets that we should be looking at. For somebody that's just getting into reverse osmosis, how would they know that everything is running properly based on those 8 data sets?
Well, that's a good question. I think number one, when you have an RO system that you are now responsible for, I would say step one is 100% partner with a company that can do a water analysis and a projection. So you know what recovery that RO system should operate at and the appropriate flux and really dial that in first and also help you with like any pretreatment chemistries that need to be in place to make sure you inhibit scale formation and all that kind of stuff. Really start over with that RO and get it set right. Now from that point on, then when you collect these 8 data points, you're collecting your flows, quality, and temperature and pressures. That way, then by using a normalization software program, and you can go to FT norm or search for FT norm with Dow, for example. I know Torre, all these memory manufacturers have these free to use spreadsheets. You can enter in the data and it'll give you normalized values. Now it's up to you to be able to interpret them. And that's relatively easy to do, to interpret the data, but you do need a little education on how to do that.
You mentioned pre-treatment. What are some of the most common things that we need to look out for before it sees the RO?
Yeah, that's a great question. Pre-treatment is the key to everything. And basically with pre-treatment, you want to condition the water so it's ideal for the RO membrane. The RO membranes are very sensitive to any oxidizer. So you definitely need to remove chlorine, chloramines, or any oxidizer that's in the feed water. That's number one, because when an RO membrane is damaged by an oxidizer, it's irreversible. It's done. And it's very expensive to replace. You might have to replace 72 or more membranes, and that's very expensive. So number one, you want to remove an oxidizer, and that's usually done either with a granular activated carbon or sodium bisulfite injection. Those are the 2 common methods. Remind me later, I'd like to touch upon that again. You want to inhibit scale growth. I mean, you want to delay scale formation within the RO system as long as possible. You want to get the water through the RO system without forming scale and let it go to drain to concentrate, and it can form scale later in its life. We don't care about that. We just don't want it to form on the membrane surface. So there's antiscalants you can inject, and there's various antiscalants available on the market. Again, you need to do a water projection to really dial in what antiscalant should be used. And water chemistry changes often, so it's a good idea. It's just like getting your annual physical at the doctor. It's a good idea to go to get a projection done, let's say once a year, and make sure that your pretreatment chemistries are dialed in properly. So antiscalant is probably the most popular. If you overfeed it, it's okay. It's not ideal to underfeed it, but it's not the end of the world. You can also use a softener, ion exchange softener. That has its advantages and disadvantages. Some people inject acid to lower the pH in the feed, but typically with all of our customers, we have, after the RO, we have ion exchange, like mixed bed ion exchange tanks. And when you add the acid, it creates a lot of CO2, and it really burns out the mixed beds on the back end. So we really don't see that often. I would say antiscalant and either sodium bisulfite or activated carbon are used in the pretreatment. And then last but not least is you really want to reduce the amount of suspended solids in the pretreatment, because so an RO system is really, it's such a fine filter that it's really meant to remove dissolved solids, and it will remove larger suspended solids. However, it's going to plug up in a minute. So typically, again, like you have a multimedia filter, that's before the RO system to remove the bulk of suspended solids. It might go down to 10 microns. And then more and more these days, you see a UF in front of an RO. I think it's somewhat slow to adopt because people have a well-functioning multimedia filter, and they just, it's a big expense to make that change. So really, those are the three things: suspended solids reduction and removing any oxidizer, and then finally, some type of antiscalant. And the reason you would add that antiscalant is you want to operate the RO system at a high recovery. You don't want to send a lot of water to waste. So by using an antiscalant, you can really up the recovery to its highest possible level.
You mentioned ultrafiltration. One, how do we define ultrafiltration? And then what's the benefit of that over just a multimedia filter?
Ultrafiltration is also a form of membrane treatment. It's a little bit looser than a RO membrane, but the UF is going to reliably remove the suspended solids level down to, let's say, 1 micron. And you might double check me on that, but very consistent level. And that's going to outperform a multimedia filter by far. And again, it's just a more consistent quality level that you receive from a UF. So again, you're seeing that more and more. And I think it's a great thing. I think the UF will be married with ROs into the future. And if you're considering purchasing a new RO system, I would definitely look at UF in the pretreatment versus a multimedia filter, even though it may be more expensive.
And the whole reason we're talking about pretreatment is to try to keep those membranes as clean as possible, as long as possible. Let's talk about when they're not clean, when they're not functioning properly. And one of the big issues is biofouling. So, what should we know about biofouling? What should we be doing?
Yeah, biofouling is a huge issue. And unfortunately, again, we have to remove chlorine and chloramines. We have to remove the oxidizer prior to the RO membranes. And if you could figure out how to create a chlorine tolerant membrane, then that would be great. So biofouling it's going to happen because we're removing chlorine before the RO system, and any bacteria or living thing that makes it past into the RO system is just going to thrive. There's a big food source in there, and they're going to grow. So biofouling is a big problem. It's very common. And with biofouling, you'll see all the normalized data give signs that, hey, this membrane is fouled, and it's essentially time for cleaning. One interesting thing when we're talking about normalized data, I think we might be jumping ahead a little bit down the road, but so we have normalized permeate flow, and we also have normalized salt rejection. We have normalized pressure differential. Well, one thing with biofouling is typically when normalized salt rejection begins to decline, that indicates you have, an issue with your membrane. There's fouling, scaling. It needs to be cleaned. It's not rejecting the salts like it was during baseline data was collected. However, it's an interesting phenomenon when biofouling takes root in these membranes, a lot of times the normalized salt rejection will increase. So your salt rejection will actually improve, but it's just this biofilm that's sealing all these imperfections in the membrane. So it kind of gives you a little boost and then it doesn't. So it's just a weird phenomenon that puzzles a lot of people when they're looking at this data.
When it comes to fouling, normally that initiates some sort of cleaning procedure. How do you know, one, that yes, I do need to clean the membranes? And how do you know you're cleaning them the right way?
Well, that's a good question. So if you look at the normalized data, there's a question of, okay, when do we clean? And if you look at all the literature on the market, the membrane manufacturers and pretty much anyone will tell you, hey, when your normalized permeate flow drops by 10 to 15%, it's time to clean. However, I think that's absolute garbage. That number was put in place to basically protect the membrane manufacturer. So it's like a warranty requirement. And I've never seen anyone successfully submit a warranty claim on a membrane. But if you clean at a 10% drop, you're going to be cleaning nonstop. And if you clean too much, you're going to affect the membrane's ability to reject salts. You're going to harm the membrane. You can't just clean these membranes every day. But the idea is that you want to definitely trend this normalized permeate flow drop. It'll decrease. It's somewhat site specific. You have to determine how often you're able to clean. Typically, you might clean once every 3 months. And that's just inevitable. You're going to have to clean these membranes. So you're gauging this drop in normalized permeate flow. You can also look at normalized pressure differential, and that will increase. You'll start to see that increase. And that's that feed water spacer that's becoming plugged with foulant or scale. And again, you also look at normalized salt rejection, and oftentimes you'll see that in decline as well. Then it's time to clean. And people either have a clean in place system that's adjacent to the RO system, or you'll actually shut down the RO system, remove the membranes, and they're taken off site. We have an off-site cleaning facility here at our plant, and the membranes are cleaned, and then they're pre and post tested to see the improvement, any issues. Some membranes are just done; they're not going to be of use anymore, and then they're returned to the customer and reinstalled. So I don't know if that answers your question. Again, it's somewhat simple, but also somewhat very complicated and site specific, and people they have different appetites for the amount of cleaning that they're able to really do.
It seems like anybody that's been involved with ROs for any period of time has some success stories, has some failure stories. I'm kind of curious. You've been in the business for a very long time. Any stories you want to share around the RO and maybe even cleaning the membranes?
Well, I think we've made every mistake in the book. It's hard to single out, give you one single story, but I will tell you a funny story that happened during the pandemic. The kids were homeschooled and we really wanted to take a trip. So the only country you could travel to, I think, was Egypt and Mexico at the time. So we went to Egypt and we ended up on these camels in the middle of the Sinai Desert one night. And we stopped at this little like Bedouin village. And, we were exhausted and hungry. And I sat down. They have like these rugs and carpets and stuff. And we sat down to have dinner. And the second my butt touched that pillow, I knew that there was an 8-inch membrane underneath that pillow. I just, and sure enough, I was right. I peeled back the blankets and there were hundreds of RO membranes, these 8-inch RO membranes that were being used as the foundation for like this entire village. There was a fence line that consisted of RO membranes. And so, immediately I kind of woke up and I found a guy that spoke English, and I'm like, "What? Why are all these membranes here?" So I think it was like his brother that worked at a desal plant in town, and they use the water for the resorts there. And he said, "Yeah, I mean, they get dirty, and then we just throw them away." And so we had this conversation, and I tried to explain what we're talking about now about being able to kind of proactively get ahead of issues and clean the membranes, and you don't have to throw them away every time. So I don't know if that ever went into practice out there, but I thought that was really funny. And that's not uncommon. And I don't blame any operator for making these errors. I mean, this is I think about equipment and appliances like we have at home, like a dishwasher, a washing machine. We're supposed to do a certain amount of maintenance on these machines that, quite frankly, none of us really do. And it's the same with an RO system. So go easy on yourself if you're making these mistakes, because you will, and you will continue to. And we've certainly made a ton of these mistakes ourselves. I'd share another painful mistake that we've made, and that is, so when you're looking at the normalized data, if the normalized permeate flow increases, which that shouldn't, right? But if it does increase, that typically means that there's damage to the RO membrane, and it could be some mechanical damage, but also it could be a sign of oxidation. So chlorine is being exposed to the system, and so you're looking at the data. The normalized permeate flow has gone up, and you go check the RO system, and it's too late. The chlorine has already damaged the membranes. So a big mistake we've made is over relying on normalized permeate flow to find out if there's chlorine damage to the membrane. And that's a big mistake. So what you need to do is you need to do a better job of monitoring the sodium bisulfite feed or the activated carbon bed to make sure it's doing its job. Like today, they have a Grundfos makes a great pump, a chemical injection pump, the Grundfos DDA. So it's pumping sodium bisulfite into the feed stream, but it also has the ability to shut down the RO. Let's say if the tank goes empty, or if there's a loss of prime on the pump, because the chemical injection pump might cost you, I don't know what they cost these days, $500, $1,000 or something. But if that fails, which they are prone to failure, then you might lose, 100,000, $250,000 in membranes. So don't rely on the normalized permeate flow to troubleshoot your oxidizer, making it through the pretreatment.
I mentioned earlier, you've got some great resources on your webpage. We're going to have a link straight from the show notes so people can find that. If somebody wants to talk to you more or find out more about what they should be doing with their RO systems, what should they do?
Yeah, absolutely. Please visit our website, puretecwater.com. There's a phone number in there. You can call the 1-800 number, and we have a great team here. I am by far the dumbest guy in the room here at Puretec, so there's a lot of great people here that are very good at solving problems. So we look forward to talking to you.
Well, Jed, I've got a few lightning round questions for you. If we can segue over to those, are you ready?
Absolutely.
All right. If you can go back in time and speak to your former self as your first day as a business owner, what advice would you give?
I'd probably punch him in the nose. I would say, leave your ego at the door, be humble, and, realize that this is going to be a long journey. Make sure to ask lots of questions and, be humble.
What are the last few books that you've read?
So I've read some really good books recently. One is called The Wager by David Gran. Great book. It's about a 17th or 18th century shipwreck on the southern tip of South America. And it's it's almost a combination between like Lord of the Flies and The Endurance by Ernest Shackleton. Great story. I don't want to ruin it for you, but you got to read it. True story. And then going from nonfiction over to science fiction, one of the guys here at work recommended I read Project Hail Mary by Andy Weir. And it's a super great story about Earth is doomed and the only answer is traveling across the galaxies. And it's such a great book. Great book. And usually I'm not really into science fiction, but highly recommend that book. And then I'm reading 101 dad jokes so I can keep staying in front of my kids and make sure I annoy them on their way to school.
That's the prerequisite. So you're in California. You're not far from Hollywood. When Hollywood finds out about your life, who do you want playing Jed?
I don't know. The Scooby-Doo count? I think because I'm kind of like Scooby-Doo. Every day we're just trying to solve mysteries around this place. So maybe Scooby-Doo or, it might be Forrest Gump or Rodney Dangerfield or Leslie Nielsen or some goofy guy like that.
Last question. If you had the ability to talk to anybody throughout history, who would it be with and why?
I'd want to take my iPhone back in time and show it to a guy like Galileo, the father of the scientific revolution, and and just kind of watch his brain melt when he sees this thing. I think it'd be amazing to have that opportunity to, go back into time and share some of our current technology that we take for granted, and just have a discussion around that. I think it'd be amazing.
Well, Jed, I know a lot more people are getting involved with RO, and I know for sure that we've helped a lot of people in the Scaling Up Nation today. So thank you for coming on the Scaling Up H2O podcast.
Thank you, Trace, so much. I really appreciate it.
Once again, thank you, Jed. And Nation, with more and more businesses that we serve trying to keep all of their water within their boundaries and figuring out how they can continue to use it and use it again, if you don't have an RO system that you are taking care of, I have no doubt that it is in your very near future. RO and ultrafiltration and all the things that we were talking about today, these are things that are just going to become the norm of how we do our business. If I had to make a prediction, that's the prediction that I would make, because we're always going to be trying to find how do we get the maximum use out of water. If you've ever attended the fundamentals and applications class that I teach for the Association of Water Technologies, you've heard me say that we have a tremendous amount of water on this planet. We have over 3/4 water on this planet. We have more water than land, but if we look at all the water that we have, most of it is salt water. Not that we can't use salt water, but it's not readily available to us. And because of that, tremendous infrastructure has to be built, and that is not readily available to us. Well, there's about 2.5% left over of fresh water. And if you look where all that is, it's in glaciers and places that we can't get it. So the actual amount of water that is on this planet that we say is readily available for us to use is 0.5%. 0.5. That really puts in perspective why we have to take care of the water that we are using. Now, here's the other fact. We have the same amount of water on the planet today that we've always had, but what we have different on the planet is how we're using water. I think I read it took 100,000 gallons to make a Toyota Corolla. So with that, imagine all the things that we are making and how much water it requires. And we're trying to get the most usage out of all that water, because as we continue to make things, as industry continues to grow, eventually there's just not going to be enough readily available water for us to use. So things like RO and all the different filtration that we were talking about in today's interview, you are going to see, and that is why. So there's so much information out there. You're probably wondering where you start. So you might go back to episode 35. Yeah, that's an early one. That's where I interviewed my friend Wes Byrne. And Wes Byrne is one of the authorities of, I would say, on RO. And he wrote a great book. So you can listen to that. And we, of course, have references to his book on that show notes page. Also, most recently, episode 335, Jane Kuchera talked to us about RO. And Jane was one of the pioneers that helped get RO to the marketplace. So she's just incredible, all the knowledge that she has. And she, of course, has a book as well. In fact, if you go to the show notes page of 335, you'll actually see Jane giving me a signed copy of her book. Thank you for that, Jane. That was so incredibly nice. So we have a lot of resources right here on the Scaling Up H2O webpage for you to learn more about RO. And our guest today, Jed Harris, he and his company have put together a great reference with their website. And it's got a really good primer on what RO is. And then a lot of the things that we were talking about with troubleshooting, they have a troubleshooting guide on their page as well. So we're going to have a link for that on this show notes page. So if you want to just get your feet wet, pun intended, we've got some really easy things to get you started with that. And Nation, you start learning about something and you bring it into your mind. It's amazing how you start seeing that everywhere. Oh, I didn't really think there were RO systems around. And then you start becoming aware of it, you start learning about it, and you're going to start seeing those things everywhere. When we bring new people into our firm, they've never seen a cooling tower before. And then they say, oh my gosh, cooling towers are everywhere. And then you get the disease like I have, where our family goes to Rome. And instead of looking at the Vatican, I'm looking at the cooling towers that are serving the Vatican. And my wife's just rolling her eyes. You're a water treater. You know what I'm talking about. All sorts of resources are available out there. And folks, that's really something that my team here at the Scaling Up H2O podcast has really tried to do a good job for you, the Scaling Up Nation, is how do we give you a repository of resources that you can figure out how you can learn the next thing about whatever you want to learn that next thing on. So we've got Legionella resources on scalinguph2o.com. We've got ways to improve your general water treatment knowledge. Maybe you want to take a class. We've got the Scaling Up H2O Academy. Maybe you're prepping for the Certified Water Technologist examination. We've got a course for that. We've got all sorts of resources up there. We've got ways to search every single podcast, and then all of the tools that our guests have freely given us to share with you, the Scaling Up Nation. All of that is on scalinguph2o.com, and it is for your learning pleasure. And I just want to say thank you again to the great staff here at Scaling Up H2O. It is amazing what they've done with all of our resources, and I love taking compliments for their hard work. I do it all the time whenever you see me out in public. But Nation, I got to tell you, I might help create the content. They are the ones to make sure that you know where to find it. So thank you, team, for all that you do. Speaking of content, we, of course, have our friend James McDonald coming to us each and every week, helping us with new content, trying to get us to think a little bit differently about our day-to-day, trying to get us to go a little bit deeper about our day-to-day. So here is a brand new installment of Drop by Drop with James.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment, you guessed it, drop by drop, together. In today's episode, I have a what if. What if the temperature of the makeup water feeding an RO decreases? How would a lower water temperature impact the RO's performance? Will it impact the quality of the permeate water produced? Will it impact salt passage across the membrane? Will it impact operating pressures? Will it impact dechlorination chemistry if used? Understanding the impact of temperature on water treatment systems can be important troubleshooting knowledge to have. I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
James, as always, thank you for that. And Nation, if you want to catch up with Drop by Drop with James, well, you can go to our website, of course, scalinguph2o.com, and you can see each and every Drop by Drop with James. So don't worry if you missed a few. You can backtrack and you can get caught up. And there are so many people that have done every one of the 52 challenges that James brings to us each and every year. James hears about it through his social media or when he's at a conference. I'm always around him and people go, oh my gosh, you two are together. Can I get a picture? And then they normally say, I love doing your challenges. So if you want to make sure that you do all 52, we're going to make that very easy for you on our show pages. So scalinguph2o.com. Nation, I love bringing this show to you. I love meeting new people like Jed. I love bringing you friends on the show like Scott. And I love it when I get to meet you out there in the Scaling Up Nation. So if you go to one of the events that I mentioned and I am there and you were there, please, let's make sure we meet each other. I would love to shake your hand. Thank you for listening to this show. And I'm going to thank everybody in advance for listening to next week's brand new show. Until then, have a great week, folks.